Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, we're going to look at more examples related to Bivariate discrete case. Okay, so here we've got two random variables. We've got x and y, and they are both discrete random variables, and they are defined together in a joint sample space. Okay, so in this example, we are going to determine what's the value of k so that this function here can serve as the joint probability distribution. Now, in order to be a joint probability distribution, this is the conditions that it has to fulfill. So the first one is each probability associated with combination of x and y has to be greater than or equal to 0. And when you add up all probabilities of that, the answer should be equal to 1. Okay, so now we're going to find what's the value of k so that this function here can become the joint probability distribution. Maybe the easiest way is to try and visualize how it looks like if you present it in a proper table. So here we've got like x, and the value of x is 1, 2, 3. And then we have also these random variables with values 1, 2, 3. So we've got the value for y is also 1, 2, 3. And here we've got this table. Okay. And so we have a few combinations that we can consider for x, y, and for x and y. Yeah. So basically what it says here is if you have x1 and y1 and you substitute into this function, then the result is going to be equal to k. So that is the value of this function here. So the value here is going to be equal to k. Yes, you just substitute the value of 1 for x and the value of 1 for y. And in a similar manner, if you substitute the value of x2 and y1 into this function, then the result here is going to be equal to 2k. So this is the result of this function here. Okay, so following the same idea, we're just going to substitute values of x and y accordingly. So for this one, you substitute 3 and 1 and 3 into this, you will get 3k. For this one, you will get 2k. For this one, you will get 4k. This one, you will get 6k. This is 3k, 6k, and 9k. So these are all the values associated with this given function here. In order to be a joint probability distribution, we should know that adding up all these values must be equal to 1. So that's how we're going to find the value of k. So you're going to add up k plus 2k plus 3k plus 2k plus 4k plus 6. Okay, this is going to be too long. I'm just going to write in this manner because you can see like a clear pattern to that. So what I'm going to do is I'm just going to write, so k plus 2k plus 3k plus blah blah blah. So we're going to add up. So here I'm just going to write a statement here, add up all the values in the cell or in the table. So we've got k plus 2k plus 3k plus blah 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 in the same manner, and the last value is going to be 9k. Must be equal to 1 if you want to be the joint probability distribution. So what is on the left hand side? So here we got 1, 2, so 1 plus 2, 3, 6, 6, 8, 12, 18, 21, 27, 36. So we've got 36k is equal to 1, therefore k is 1 over 36. Okay, so k is 1 over 36, and clearly if k is 1 over 36, all the values here are definitely going to be greater than or equal to 0. Yeah. So that's the value of k, so that this function here can be the joint probability distribution. Okay, now let's move on to the next part here. Well, we have x and y, two discrete random variables, and then we might be interested to find the joint cumulative distribution or joint distribution function or joint CDF of x and y. Okay, so we are using the same notation big F, but here we introduce another random variable, so we have the combination of x and y together. Okay, so basically remember what we have done in the previous discrete case. One random variable where we have x is a discrete random variable, and so if you want to find fx, we are actually interested with finding x less than or equal to a certain value x here. So if we have x and y together, it is only natural that we extend this part here to include another random variable, and this part here to include another random variable as well, which is going to be called y. So basically it's just extension and making the mathematical expression slightly longer. Okay, right, and here we've got some summation process. So we have these two notation or mathematical symbol here, sigma. So sigma here denotes adding up all the values. Okay, now let's look at this example here. Based on the result obtained in example 3.9, find this value right here. Okay, so we're going to start off with that one. F11. Okay, so what does it mean really? It means you want to find the probability x less than or equal to 1, y less than or equal to 1. And if you see the formula given here, it says something related to having this sigma. So here we've got S. I'm just teaching you what's the interpretation of this mathematical expression right there. Okay, so basically what it says here is s less than or equal to x. That means here we've got s less than or equal to small x, which is this one. So s less than 1. Similarly, t is also less than or equal to this value here, the small y. So t is less than 1. And here we've got f s t. Okay, so what it means really is that we're going to continue substituting this value into here. Okay, and we're going to do it systematically, and we're going to consider all the values that is less than or equal to 1. So for example, we can start by substituting s equal to 1 inside here. So we've got f1, and then we're going to substitute t equals to 1 into here. So we've got 1 1, and then we're going to maintain, and then we're just going to like continue in this inner cycle first. So we're going to maintain 1. So here we've got like f1, we'll maintain s equal to 1, and we're going to think if there's any other value of t that is less than 1, maybe 0. After 1 is going to be 0. Yeah, and then is there any other value of t that is less than 1? For example, is there a value of t equal to -1? Well, in this case, no. So we're just going to stop right there. Okay, we're going to stop right there. And then what we're going to do is we are going to consider changing this value. So this value is going to move from 1. So here it's maintained at 1. So now we're going to change it to a value that is less than 1, because here it says s less than or equal to 1. So we're going to change the position on this outer circle, yeah. So this one is inner, this one is outer. So now what we have to do is we're going to change that to f. So change it to 0, okay, and maintain this at 1. So we start with, again, t is less than or equal to 1, so this is at 1, and then we move on this guy here, this is maintained, so f 0, and less than 1, it can be 1, it can be 0. So here basically that's what it means, okay. This mathematical notation or expression, this is what it means really, okay. So when you look at the table, here, we see that the values for this one, 1 is this, okay, 12 over 72, plus 1 and 0. 1 and 0 means x1, y0 is this one, so this is 24 over 72, plus this one, 0 and 1. 0 and 1 is this one, 16 over 72, plus 0 and 0 is this one, 12 over 72. So you add them up and you'll be able to get the answer is equal to 64 over 72. Yep. And you can simplify if you want. So if you simplify, the answer is 8 over 9. Okay, so that's the first question. Another way of trying to solve this is by looking at the table and consider which area that corresponds to value of x being less than or equal to 1. For example, this is the area where x is less than or equal to 1. So this area going in this direction. And then we can consider which area where y is less than or equal to 1. So less than or equal to 1 is this part. So the probabilities that we have to add up will be the probabilities that are comprised within this area really. Okay, so that is another way of seeing it or solving this problem, yeah. Okay, so let's move on to the next question, which is finding f negative 2 and 1. Okay, so for f negative 2 and 1, you can see that negative 2x negative 2 doesn't exist really. Okay, so negative 2 doesn't exist, negative 2 is somewhere here, it doesn't exist, okay, somewhere in this direction for x. So if it doesn't exist, the combination of y with any value of negative 2 and less than that, okay, because f negative 2 1 basically means you are finding probability of x less than or equal to negative 2 with y less than or equal to 1. Of course, this part here, you can see it clearly from the table. We have values of y from 1 and less than that, so we have in this direction there are some values, but then negative 2 is outside the range already, so there is no combination possible for these two random variables to happen together. Therefore we can just say the answer is 0 really, because it is outside the range. It's outside, yeah. Now for this one, for the next one here, f 3.7 and 4.5. Well, for this one, this is basically saying that you are interested to find probability x less than or equal to 3.7 and y less than or equal to 4.5. And since this is a discrete case really, so we can go to the perhaps the highest value of x, because here this is 3.7 already exceed x, yeah, x here, the highest value of x is 2, so probably this is going to be, can be written as finding probability x less than or equal to 2, and y again 4.5 is somewhere here, so already exceed the highest value of y, so maybe here we can say y is equal to 2 as well. So that is what we can do for this question. And really you can see that if this is 4.5 is situated somewhere here, okay, and then this is sorry, if 3.7 is situated somewhere there, right there, yeah, so 3.7 is already outside the range in this manner, and also similarly 4.5 is also out of the range. Okay, so that means the probability of that happening is going to be equal to 1, because you are considering all the range from 4.5 upwards, from 3.7 in this direction, so you will cover all the probabilities associated with that, and all these probabilities, when you add them up, it will be equal to 1. Okay. Okay, so now let me just explain to you how this can be written or mathematically described using this process. Okay, I'm just going to describe this process, especially this double summation here, where some students might find it difficult to understand what it really means. Okay, so we're just going to illustrate that process here, although you already know the answer is 1, but let me just illustrate to you this idea. Okay, so basically when you have this one, according to the formula here, it says that you are looking to add the probabilities of having s less than or equal to the value of x. The value of x is 2, so s less than 2. Similarly, t is less than or equal to 2 for this one, 2. And here we've got f s t. Now think about it as this one is the inner circle where you're going to change this part first, and then this is the outer circle. Okay, this is the outer circle. Okay, related to these changes. So first we are going to set the outer circle here with s being equal to 2. So here we're going to consider s, taking the value of 2. Okay, we're going to consider outer circle. And then t is also equal to 2. Okay, so now we're going to talk about t. T is also going to be equal to 2, because it starts with less than or equal to 2, less than or equal to 2. So this is the value. Next, we are just going to change the inner part first and maintain this value here. So what we have is we are going to change the inside first. So 2 is going to be maintained until everything is changed, until everything inside is changed. Well, that means we're going to systematically reduce the value of t. So from 2, we're going to call it, change it to 1. Okay, so t is less than or equal to 2. So it can be 2, it can be 1. Okay, this is the value of t, so it can be 2, it can be 1, and then we're going to move it until the end of it, which is 0 plus f2, and the value of that inner circle is 0. You understand what I'm doing? So basically I start with having the outer value here set at 2 and 2, maintain it at 2, and then focus on the inner circle here where it get reduced from 2 to 1 to 0, and it stopped at 0 because this is the last value for t. T is actually related to y. Next, okay, next we are going to move on to plus f. Now since 0 is the lowest value for y, then we are going to move this part here. So this part is going to be set to 1. So after 2, it's going to be 1. So 1 is going to be maintained, and we are going to consider the inner circle. So it starts with 2 again, back at 2. So here we've got it start at 2 again, t less than or equal to 2, yeah. And we are just going to change this first. The inner circle is going to be changed or reduced to the next number, which is going to be equal to f1, and here we've got after 2 it's going to become 1. We can see that here is maintained, 1 and 1 is maintained, the outer part here is maintained, and then we're going to plus f1, and we're going to change the inner part here, which is going to be 0. Okay, so we stop here because the value of 0 is the lowest, so we know we cannot go and change it further. So now we start with changing 2. We start with setting x equals to 2, and then we move on with 2, 1, 0. And the next level, we start with moving with x1, and we go back to 2, 1, and 0, the combination of all this. So now, with this process, we're going to continue with f, and this part here is going to be reduced to, here we got 2, 1, and so we got to consider 0, and we're going to start off with this part 2, so we go back to y equals to 2 or t equals to 2, and plus, okay, 0 is maintained, the outer part here is maintained, and you're going to change the inner part, so the inner part is 1. Okay, so the inner part is 1, then plus 0, and the inner part is going to be 0, and we stop because we have covered the last one, which is x is set at 0, and then we start considering 2, 0 and 2, 0 and 1, 0 and 0. So basically what I just demonstrated to you is understanding what it means by this mathematical notation of having a double sigma here, okay? Right. And you can see that by doing that, we have covered all the probabilities in each cell here, and by doing that, you will get the answer here is going to be equal to 1. Okay, that's all for now. Thank you very much for watching.